All right, guys, here we are on CLT math practice number 3. Question number 107. If the length of arc AB is 2 pi units, then which of the following is true? The radius of the circle is 2 units. Well, let's see. If this little piece is 2 pi, then the circumference of the whole thing, like that's 1/4 of it, right? We would multiply by 4. So the circumference equals 2 pi times 4 equals 8 pi. And I know from the reference sheet that the formula for circumference is 2 pi r. So the radius is not 2, it's 4. The diameter of the circle is 8, not 8 pi units. The circumference of the circle is 4 pi squared units. No, we don't square our pi in circumference. And the area of the circle is 16 pi. Area of a circle equals pi r squared. We just said the radius is 4. Pi times 4 squared is 16 pi units squared. D is correct. And then question number 108. Point A in quadrant 2 of the unit circle below is rotated around the origin until it rests on its image. So point A here gets rotated around counterclockwise, right? All of our answer choices say counterclockwise until we get to here, which lies on the x-axis. Yes. Which rotation could describe the transformation? So we went 90 degrees, 90 degrees, and like 45 degrees. I know that the entire circle is 2 pi radians. They give you that on the reference sheet. So that means that pi radians, 2 pi radians is 360 degrees. Pi radians is 180 degrees. And pi over 2 radians is 90 degrees. And pi over 4 would be 45 degrees. So if we moved 45 degrees that at a time, that'd be 1, 2, 3, 4, 5. We moved 45 degrees 5 times to like get around. So that'd be 5/4 pi would be 45 times 5 rotations. So our answer is C. And then number 109 says, after doing some research, Alex comes up with the following rule. The magnitude of the surface area of every cube is greater than or equal to the magnitude of that cube's volume. Which of the following is a counterexample that disproves the statement? Okay, so we're going to look here. Magnitude of the surface area of every cube is greater than or equal to the magnitude of that cube's volume. So we want to compare the volume and the surface area. To find the volume of a cube, you just say side cubed. 1/2 to the power of 3 for answer choice A, 1 cubed for B, 7 cubed for C, and oh wait, no. B does not say side length. B says volume. My bad. Get that out of there. When the side length is 1/2, you just cube it, right? Side length of is 7 for C. So I'm going to start with these two where they give us the side lengths. And what's the surface area? You would take the side length, square it, and surface area of a cube is going to have 6 sides. So multiply it by 6. Okay. And then, so for this one, side length squared times the 6 faces of the cube. 1/2 times 1/2 is 1/4 times 1/2 again is 1/8. 1/8 cubic meters for the volume, and the surface area would be 1/4 times 6 would be 6/4, where the magnitude of the surface area is greater, and the surface area for A is greater than the volume. C, we've got 7 times 7. Oh, look at that. 7 times 7 times 7. And over here you have 7 times 7 times 6. So that means the surface area is less than the volume. So this is a counterexample because you're multiplying the same numbers. This one you're multiplying it 3 times. This one you're multiplying it 2 times. And then one less. It's going to be less. We don't have to check it. We know it's going to be less. And then number 110. For which of the following integers is it the case that the total number of its distinct factors equals the sum of the integer's digits? Well, first of all, what are the sum of the integer's digits? 3 plus nothing. 3, 1 plus 6 is 7. 2 plus 4 is 6. 3 plus 6 is 9. How many factors do we have of 3? Our factors would just be 1 and 3, which is not 3. Our factors of 7 would just be 1 and 7. That's prime, not. Oh, I'm sorry. Our factors of 16 would be 1 and 16, 2 and 8, 4 times 4. We have 1, 2, 3, 4, 5 of them, not 7 of them. Our factors of 24, you have 1 times 24, you have 2 times 12, you have 3 times 8, you have 4 times 6, you have 1, 2, 3, 4, 5, 6, 7, 8 of them, not 6. So we got to go all the way to the last one. Our factors of 36, you have 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. Question number 111. A right triangle has an area of 12.5 square units. Its hypotenuse measures approximately 7 7/100 units, and the tangent of one of its acute angles is 1. What are the measures of its angles? Well, it's going to look something like hypotenuse. So we got a right triangle, hypotenuse across from the 90 degree is 7.07 units. If the tangent here, tangent of A, equals to 1. My tangent is my opposite over adjacent. So whatever this is and whatever this is, they're equal, which means these two angles are equal. So you've got an isosceles right triangle, which is 45, 45, 90 degrees. And question number 112 says, the curve for y equals the square root of x is stretched vertically by a factor of 2, then shifted down 3 units and right 5 units. What is the equation for the resulting curve? So stretched vertically by a factor of 2. Look at that. All of them did the same thing. They multiplied it by 2. There wasn't a 2 there. Shifted down 3 units. That's going to be where you subtract 3 on the end, not 5. And then shifting to the right by 5 units. When we do this, right, you've got your graph of your line, whatever it may look like, and you're shifting it to the right by 5 units. Whenever you do this, you actually wind up subtracting that from your x minus 5. So our answer is A. And that's going to be it for this video, but I'll catch you back on the next one for question number 113.